Now let's go through this example together. We have to integrate a fraction again, but if you look closely, this is an improper rational fraction. This means that the degree of the numerator is greater than the degree of the denominator. So before we can integrate it, we need to simplify this expression. We're going to be converting it into improper fraction, and we write it as quotient plus remainder over divisor. So let's do that. We will divide the numerator by denominator, like this. First, divide the leading term of the numerator, 3x squared, by the leading term of the denominator, which is 3x. So this will be giving us x. So the first term of the quotient is x. Now multiply x by the entire denominator. This will be giving us 3x squared plus 2x. And now we will subtract this from the original numerator. This will be giving us 0. And this minus 7x minus 2x will be giving us minus 9x. Next, divide minus 9x by 3x. This gives us minus 3. So the second term of the quotient is minus 3. Now multiply minus 3 by the entire denominator. This will be giving us minus 9x minus 6. And subtract again. This minus 9x plus 9x gives us 0. And we are going to be left with positive 6. So the quotient is x minus 3. And the remainder is 6. So now we are going to be writing our original expression in this form. Now we integrate each term separately. The integral of x is x squared divided by 2. Integral of minus 3 is minus 3x. And for this, we use substitution, where the 3x plus 2 in the denominator is going to be placed inside the box. Its derivative is 3. So we divide the numerator by 3 to balance it. Hence, we are going to be writing 2 ln 3x plus 2. So let's rewrite this, and let's write our final answer. Now let's do this example. This is a fraction where the denominator has a square root. Our goal is to integrate this step by step, just like we did before. First, we are going to be placing the denominator inside the box and see if its derivative is found in the numerator. So let's do that. You can see that our numerator is 3x plus 2. And so this is not the exact answer we are expecting. Hence, we cannot apply the logarithmic rule here. Next, let's try putting what's inside the square root in the box, and let's find its derivative. Again, we can see that it is minus 2x, which isn't matching the numerator, so we cannot apply the power rule. Now we'll be giving it a different approach. Since direct methods didn't work, let's split the fraction into two simpler ones. We're going to be calling this W1 and this W2, and work on them separately. So let's do W1 first. We're going to factor out 3 from this integral. So we're going to be left with this. Now, like we used to do before, we will first place the entire denominator inside the box, finding the differentiation of the box. You can notice that the differentiation of the box is not found in the numerator. So let's place what's inside the under root inside the box and find its differentiation. We can see that it is equal to minus 2x. So we will be just introducing a balancing factor, minus 2 outside and inside the integral. And now we can apply the power rule. Now we have completed W1. We'll move on to W2, working 2. To handle this again, we will first factor out 2 from the integral, hence we are going to be left with this expression. If you recall, it matches the standard form of the sine inverse integration formula. So you can see that the numerator has 1, hence we can apply the sine inverse integration formula directly. So we are going to be left with this. Now that we have completed our first and second workings, we will be placing W1 and W2 back together and write them as a final answer. You can notice that we have only written plus C here because this plus C denotes both the addition of C1 and C2, writing it as simply C. In this example, we'll be expanding a power using a trigonometric identity. We're given this expression, secant x plus tan x whole squared, and we need to integrate it. Our first step is to expand the square. So we're going to write it as secant square x plus 2 secant x tan x plus tan squared x. Now let's think logically. We already know that the integral of secant square x is tan of x. So let's take a look at the tan squared x term and simplify it using trigonometric identity. The identity is 1 plus tan squared x is equal to secant square x. Now we are going to rearrange it to make tan square x the subject. So tan squared x is equal to secant square x minus 1. Now we substitute this back into our expanded expression. So we get secant squared x plus 2 secant x tan x plus secant square x minus 1. Now let's simplify the expression. Secant square x plus secant square x plus 2 secant x tan x minus 1. That is equal to 2 secant square x plus 2 secant x tan x minus 1. Now we integrate each part separately. So split it into separate integrals. We're going to write it as 2 integral secant square x d of x plus 2 integral secant x tan x d of x minus 1 d of x. And now we are going to be applying basic integration rules. We know that the integration of secant square x is equal to tan of x. For secant x tan of x, we are having the integration as secant x. And for 1, the integral is x. So let's write our final answer. 2 tan of x plus 2 secant x minus x plus c. This is our final answer.